So what I have here on the screen, it's just a visual diagram of all the possible outcomes that could happen when you are rolling two die, or two dice, actually. All right. And this is just laid out very simply. You have the blue up at the top, so and then the for the row, and then the column is in red. And so that shows you that 6 times 6, which is how we looked at in 10.2, called the fundamental counting principle. If you have one die that has 6 possibles on it and another die that has 6, multiply 6 times 6. So there's going to be 36 different ways that you could have that experiment shake out. You can kind of see here. Since they're both identical, it doesn't really matter which one is which die is what, but you'll see like the first one is 1 1, and then they do all of the ones where the first number is 1 and the second number changes. Then they go down to the second row, which is where the first number changes to 2, and then the last number changes on all the rest. And you can see it goes down through there, and you can see all 36 outcomes. Hello, Essence and Catherine. Hope y'all are doing well. All right. So what we have then is this little chart, I guess you would say it. We're going to learn about a couple of different ways to do this, and then learn why it's not always feasible to draw out your sample space. Now, it asks here for the examples to find the probability of getting a sum of 9. What do you think that means, a sum of 9? Like on this first one right here, if you was to put an addition sign in between,
adding them together.
Yeah, 1 plus 1, so that would be a sum of 2. This one would be a sum of 3. This one would be 4,
5,
5,
4.
6, 7. So where do you see one that actually is 9? So this is 3, 4, 5, 6, 7,
5, 4.
8. So this one is 3 and 6 right here. So 3 and 5 is 8. So here, right here on that first one right here, on row 3, I'm just going to list it on here.
Mr. Cruz, there is also on row 4. 5,
yeah, there's
4.
more than one. I'm all right, but I'm just kind of going orderly.
Okay.
So we make sure we get them all. So there's one of them. All right, and you said which one? 4 and 5?
Yeah, 5, 4.
Yeah, we'll get to that one.
Oh, you're still on the other row. Okay.
Yeah, see, 4 and 6.
Yeah, 4 and 6.
That's 10. And then you go down here to the last row. 5 and 3 is 8. So here's the one you was talking about. 5, comma 4.
Wait, why is it 4, 6? 4, 6 makes 10. Isn't it supposed to be 9?
Oh, I'm sorry. I thought it said, I was thinking it said greater. You're right.
You're fine.
You're right. Thanks. I'm thinking of this one right here. I was looking at it. It says greater than 8. All right. So now 5, 4. And are there anyone else? I think there's also 6 and 3. So is that all the ones that are 9? As a matter of fact, you can kind of just look at this line running across here, this diagonal. 6, 3, 5, 4, 4, 5, and 3, 6. So if you kind of follow that line, you can see them all in that kind of a catty-cornered row. So there are 4 with sum of 9. So probability of is equal to 4 over 36, because there's 36 of them, which is whittles down to 1 over 9, right? Did I do that right?
That's right.
So 1/9 is probability. Now you got to watch out what you're asked for. If they say a simplified fraction, you would put 9. If you ask for a decimal, you got to watch what they ask for. This would have to be rounded off to some space because it's one of those repeating decimals. So just watch out what they're asking for.
Wait, Mr. Cruz,
Mm-hmm.
your voice was cracking up. Okay, so I didn't see when you did the answer. So it says there are 4 with sum of 9. So is
Mm-hmm.
that the formula where it says p sum 9, or is that
Yeah,
the
it's just
answer?
saying the probability of those that have a sum of 9 is 4 over the total of 36.
Okay, so how did you get 36? Did you add them or?
Look, 6 times 6 is
Oh,
36.
okay. Oh,
36
okay.
total ones. That goes back to the fundamental counting principle. So if we have a die that has 6 on one side and 6 on the other, well, when we
Gotcha.
put them together, 6 times 6 gives us the 36. And you can
Okay.
also count them out if you wanted to.
Yeah, yeah.
But what's important is, and the reason why I'm telling you about the fundamental counting principle, is it's more important how many there are by just multiplying 6 times 6 than really necessarily seeing them all. All right, here's another one. Find the probability of getting some that is an even number. All right, so here's 1 and 1 is 2. This one's odd, so this one, 1 and 3 is 4. That's even. This one's odd, and so that's even. So there's 3 on the first row that are even, right? 1, 2, and 3. So remember that, 3 on the first row. All right, this one is odd. This one is 2 and 2 is 4. That's even. So 1, 2, and 3 there as well. You notice a pattern? Now 3 and 1 is 4. That's even. This is odd. 3 and 3 is 6. That's even. 3 and 4 is 7. That's odd. 3 and 5 is 8. That's even. 9. So what does that say? It means there's going to be 3 on each row. So that's 3 times 6. 18. Does that make sense? Well, let me put up here. Put the formula. All right. Makes sense? Look at it and let me know if you see something on it that doesn't look right. I want to do some roll checking. All right, does that make sense? Half of them are going to be even. Half of them are going to be odd. All right, so now we've got sum of two numbers, which is greater than 8. If the two numbers are going to be greater than 8. All right, again, the good thing about this kind of a thing, like seeing them, you can kind of pick out a pattern. All right, so now we want greater than 8, so not including 8. So none of these are going. None of the first row is going to suffice because 7 is the highest one. This one is the last one is 2 plus 6, which is 8, but that's not greater than 8. So the first one is 3, 6, because that's 9. That's greater than 8. Here's 4, 4, though that's 8. So now we got 1, 2, 3. And then we got 4, 5, 6. And then we got 7, 8, 9, 10. Are y'all hearing me all right? I'm not hearing any.
Yeah, fine.
Yeah,
Okay.
so far so good.
Usually somebody's saying something, so some. So I said that there was 10 over 36. So 5/18. All right. Any questions about any of those with the dot? We're going to go through several different scenarios here, so not that big a deal if you got questions, because I want to make sure we thoroughly understand the concept of probability. Because really, we're going back to the very first section 1 where we started looking at probability. It's just now we're kind of looking at more complex ones and seeing the sample space so we can figure out the probabilities.
So basically, all you did for the last problem was just add the two numbers together and see whichever
Yeah,
one.
let's look at this one right here. 6 plus 3 is 9. We're not including this one because that's 8. It's got to be greater than 8. So we have
Yeah,
1, 2, 3, 4 there.
yeah,
Here
it's
it
easier to
starts
go back
1 over.
rows.
It starts 1 over. So 5 and 4 is 9, 10, and 11. So now we got 4, 5, 6, 7 over here. Here's the 2 that are greater than 8. 8, 9, and then the last one, 10.
Yeah, I get that part. So would the problem be wrong, Mr. Cruz, if we didn't include like probability sum greater than 8, or
Well,
you
then
said,
what would you put there instead?
like just the answer, or you would have to include the whole thing basically.
Well, I'm showing you formally what, because this is the thing is, if you're writing it out, you want to make sure that people are following your logic, right? If I just threw a 5/18 up there, then what are people going to say? Well, where did those numbers come from?
Yeah,
So
yeah,
I'm just showing you the individual steps
yeah, yeah. It's
to kind of
understandable.
clarify.
All right, thanks.
But I mean, the most important part is you get to the right, right answer. That's more important. I mean, the steps are going to be different for everybody because everybody has a little bit different understanding. And one of the things that people don't think about in math is that mathematics, if you're looking at somebody's paper, you can easily tell whether someone's copying off of somebody, just like you can if you take an English paper and you can see it is plagiarized. Because if you have two different students, generally the steps are going to be a little bit different for everybody, because the things that people write down are the things that they can't process it in their head. And everybody's going to be a little bit different in that regard. All right, so let's go on now to look at a different kind of sample space. This is what the book, it calls it a tree diagram. And this is a tree diagram for a family that has 3 children. But it's kind of, let's see if I can make it a little bit smaller. You can see the whole thing at one time. It's an image, so there we go. Now, the way this works is, if you go over here to the, this right here, this like point right here, that's where your first 2 choices come. You're either for your first child going to have a boy or girl. So if we wanted to kind of label this first BG here going down, that would be child 1. It can be either a boy or girl. Now, it's going to be different for, not everybody's going to be the same. So that's why we have to give both choices. So if you have a boy for the first child, and then on child 2, which is the one with 4 in the column there, that's the second child. Then if you have a boy, well, you could have another boy, or you could have a girl now. Likewise, at the bottom, for the first child, if it's a girl, you could have a boy or a girl once you've had that first girl. And then the last column, the one that's got 1, 2, 3, 4, 5, 6, 7, 8, is child number 3. So we branch off of that boy to where we have a third boy or the third child is a girl. And you can see over here that they're listed out what the sample space is. Boy, 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 girl. And then for this one would be first child boy, second child girl, third child boy, boy, girl, boy. For this one, it's boy, girl, girl. And then the halfway point, now they're all going to be the first child being a girl. So girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. So now, from looking at this sample space via this little tree, find the probability of a family having at least 2 children. I'm sorry, at least 2 girls. They're all going to have at least 2 children. It's
There's 4 of them.
all right. So we can rule out the top one because there's no girls in there at all. This one's only got 1 girl. This has only got 1 girl, but this one right here has 2 girls. And it says at least 2, so we can count anything that's more. So 1, now this one's got 1 girl again. This one's got 2. So 1, 2. This one's got 2, so that's 3. And then girl, girl, girl is at least 3. So 4. And how many total are there? There's
4 out of 8,
here.
so 1/2.
Yeah. Okay. So questions about that? All right. So how about B, where it says find the probability of having all children of the same gender? Boy, boy, boy. That's all the same gender, isn't it? This has got mixed boys and girls, boys and girls, boys and girls, girls and boys, girls and boys, girls and boys, girl, girl, girl. So there's only 2 choices out of these, or 2 of the event that they're the same gender. So 2 out of the 8, which is 1, 4. All right. I can do another one from this same thing if you want, if I can think of one to do. Now this is important about the wording, so it doesn't say 2 girls or more, it says exactly 2 girls. So here's one with exactly 2 girls. Here's one with exactly 2 girls. So there's 2. There's 3, right? With exactly 2 girls? No girls, 1 girl, 1 girl, 2 girls, 1 girl,
That's
2
3.
girls, 2 girls, and we're not going to count this one this time. So it's 3, right? Okay. All right, let's see what else we got. Going through these faster than I thought it would. Hopefully come up with something else for us to do a little bit. All right. After we go through these, I'm going to try to find a sample space thing, and then I'll just make up some, and I'll let y'all do them and report back to me. All right. Because I want to make sure we got a good understanding of the probability before we go on to the next section. Because the next section starts incorporating those counting methods. All right. So we got a sample space, and it's a full deck of 52 cards. This is what they call a standard deck. Because there's other kinds of cards. I'm not sure. I know that there's one of them that's different. It's called a pinochle deck, and it's got different. It almost looks the same, on initial examination, but it's got a different number of things in it. So find the probabilities using the card layout above. All right, what's the probability? And you got to think of it like this. All right, you got a deck of cards, and you shuffle them up, and you're going to deal one out to somebody. You might even have them pick it blindly. All right. Either way you do it, the outcome's going to be the same. So what's the probability that they pick an ace? What's the
4 out of
probability?
52 or 1/13th.
Right. 4 out of 52. So 1/13th of the deck is aces, and that's what happens when you reduce it down to simplified form. You can see the proportion then there a little bit easier. 1/13th of the deck is actually aces. Probability of a face card. Now, what is a face card?
Jacks, queens, and kings.
Yeah, so let's go back up here and look. This is kind of small. Let's see if I can make it bigger for the second here. All right. So the face cards are all of these over here. There's 3 in each suit. There's 4 suits, the clubs, the hearts, the spades, and the diamonds. So there's 3 in each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you could multiply 3 times 4, and that would tell you as well. Again, it's not always necessary that you actually be able to see them and count them individually, because that's what we're going to see about the counting methods. The counting methods are a way to just tell us the number, because we don't necessarily need to be able to see exactly what they are. We just need to know how many there are. So how many are there face cards? 12. Am I right on that?
Correct.
So 12 of the 52 are face cards. And then that reduces down to 3/13. And you can kind of see, you remember for the ace, it was 1/13. Well, there's exactly 3 times as many, as there are aces. All right, let's see what else we got. So a club. What is a club? The club is the one that's got like the three. It's like a flower. It's the one up here. This top row are clubs. So how many are those? Are there? You can go through and count them. And again, doesn't hurt to do that at this point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And that means that reduces down to 1/4, right? And another way to look at probability is what's called proportion. It's really the same thing. Proportion, in this case, 1/4 of the deck are clubs. And, you can kind of see that visually by looking at that. All right, now, D. Now, we haven't talked about, we'll get something called the OR rule coming up for probability. But this we're going to just do it by counting, by looking at the sample space. But it's 4 or heart. So you're going to have to look and count. So there's 1, 2, 3, 4 hearts, right? I'm sorry. There's 4 fours. That's what I should have said. There are 4 fours. 1, 2, 3, 4. Now, just like there were for clubs, there's 13 hearts. So, how many total are either a club, or a heart, or a 4? Let me do it this way. So first of all, we got 13 here. Now we're going to add in the 4s. 1. We already counted this one, so we're not going to count it again. But we're going to count this one. So 14, 15, and 16. Because we already counted the 4 when we counted all the hearts, the 4 hearts. We counted it with that. All right, is that set up correctly? Or simplify it? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So there's 13 hearts, and then we already counting one of the 4s because it's both a heart and a 4. So then we only need to count the 4 clubs, the 4 of spades, and the 4 of diamonds. So that's 3 more added to the 13 that gives us 16. So that's 2. Oops. 4. Is that right? 8, 26, 4 13s. Correct? Is still awake out there?
Yeah, that's right.
Okay. Okay, the last one on these. 6 or 8 of spades. All right, so it's saying a 6 or an 8 of spades. Or is it saying 6 or 8 of spades? Well, I'm going to count on that it means both of them as spades because there's no comma after 6. If there was the 6 comma, it would mean that they were separating. But it's talking about 6 or 8, either one of those spades. So, how many are there that are
13.
spades in 6 or 8? 1, 2. All right. So checking those out, and I'm trying to find something else for y'all to do that you can work on, and then see if you got this concept. Because, like I said, this is important. I was trying to think of something different, but we might have to just go back to one of the sample spaces that we've got. Oh, I know what we can do. There's something in the book that was unusual. All right, I know what I'm going to do. I'm going to go over to the book and all right, so y'all doing okay?
Yeah.
All right, so let me come up with something else to. There was a neat little thing in here. All right, let me copy and paste this one over there. All right, this is another sample space using a tree diagram. All right. All right, so this is a sample space for flipping a coin. So you're going to do two things. You got a coin in your hand and you got one single die, just, 1 through 6. And you're going to flip the coin and you'll get either a head or a tail. And if you get a head, then that means then you can roll either one of these 6 numbers, and this would be the outcome. Let me think I can think of some good questions to ask here. All right, y'all try to work this out, and y'all tell me what it comes out to. You want to flip the coin, get a tail, and then roll an even number. Find the probability. I'll give you all a few minutes while I'm checking on the last roster here.
So would it be 1/2 and 1/4?
Well, but it's going to be, you're doing both of these things, so it's going to be one probability. So first of all, let me back in here. Let me just finish doing.
Three out of six.
Okay, hold on. All right. So what we want is we want to have a tail and an even number. So that leaves out anything in the first half up here, right? So none of these have a tail. They have even numbers. And then these down here are the ones that are tails. So the ones we're going to be looking at are the ones that are even number, which would include 2, 4, and 6. So that's 1 here, the second one, 2, 3. So how many different outcomes are there?
Well,
You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can also find it by flipping, by the coin number of sides is 2 times 6 is 12. And so that's 1 quarter. Now, George, I heard you say something about a quarter, but I also heard you say something about and. So maybe I didn't hear, but the quarter sounded good. Now, one of the things that we're going to find out, we're not doing it now, but there's something called the product rule, where you could look do these two properties separately, because we're saying we want a tail and an even number. Well, the probability of the tail is 1/2, because there's 1 over 2. And then the number of them that have an even number is 3 out of 6. So 3 out of 6 times 1/2 is actually 3/12. So we're going to see a number of rules popping up. There's really only about 4 rules after when we come back from our little break. And that'll make
it, but I did it both ways. That's how I got the 1/2 and the 1/4, but I didn't combine them.
Well, but it's not the one. Okay, it's 1/2 and then 1/6. Okay, actually, but you can also do it directly by just counting. Look, which one of them have a tail and an even number in it? Well, there's only 1, 2, 3. Tail 2, tail 4, tail 6. All right, let me think of another one to give you. Let me see if I can find a good question.
yeah, I did it a third way, which was there's half of them that can be a tail and half of them can be even, and if you multiply them, it's 0.25.
Yeah, that's right. Because it's 3 6.
Or just counting them straight up.
3 6 is 1/2 in disguise. Yeah, you're right. Right. Let's see. Let's see. Try something else. Not a whole lot of exciting things to do with that one. Let's see. Here we go. All right, here we go. coin flips. So each time there's 2 choices. So 2 times 2 times 2 means there's going to be 8 different outcomes. All right, so find the probability of getting a head on the first flip and a tail on the last flip. See if y'all can work that out. And again, you should be able to do these just by looking at them and counting them. There is another way to do it, like I said, using rules that we haven't looked at yet. But just try to do it by counting.
That's the same problem like in Alex, but in Alex they give you like a graph, like they give you you have to like check the boxes.
Yeah, right.
Yeah.
Yeah. They have that little neat thing, so that way you can actually count them. Yeah. Or you can count them and see them. Yeah, we don't have that luxury here. And I really
Yeah.
wish I could get and use the learning path, but I can't break into the learning path, and just go to a particular problem. You got to go in the order that they give you, and you can't move around them. So I haven't found a way to use those because those are neat. So what I do though is when we review the like the quizzes, you can do that with. They're linear there. Well, I don't say they're linear. You can go around to the problems individually. I can pull out the individual problems. So find the probability of getting a head on the first flip and a tail on the last flip. All right, so let's just go through here and examine them. Okay, all of these here, 1, 2, 3, 4, the first half, they all have a head on the first flip. Okay, is that true? Because look, on the second half of this, it starts out with tail. Now, we don't care what the middle one is, but we're looking for one that has a tail, and we're looking at only these 4 now because that's the only one that has a head. So now, how many of these have a tail in the third spot? Well, 1 and 2, right? I'm going to put it like an X there just to show that we don't care what that is. So there's 2 out of how many? 8? So 1/4. Does that make sense? Any questions about this? All right. All right. And if you haven't figured this out, It's kind of neat about the way that probability works. This right here is really the same sample space as for the 3 children. Because with the birth of a child, it's either going to be boy or girl, and we more or less, consider those equally likely. And it's not going to be that way for every family, but some are going to balance out, and that's why this thing called the law of large numbers applies. So it ends up being, 1/2 on each one of the flips of the die, of the coin, or for the child. So, it's really the same sample space. And that's what we're going to see is when you're dealing with these type of scenarios, it's not so much the number, what the actual values you're dealing with, it's how many. So what's the probability of getting at least one tail?
Seven of eight. 7 out of 8.
Okay, so the only one that doesn't have a tail is the first one. This one's got one tail, this one's got one tail. Those are all at least one. So it's really, it's all of them except for the head. I'll try one last one here.
One of 8.
Hmm?
1 of 8. 1 out of 8.
Yeah, that's good. And again, this is going to be an important rule that we're going to see, and I believe it's in I'm not sure if it's in the next section, but it's the section afterwards. So there's another rule. As I said, is you got what we call the and rule, the or rule, and we actually saw these kind of being built, but we did them by counting. And you'll find out that to do these compound things where you either got an or an and, you can either do by addition or subtraction. By addition or multiplication. Now, this right here of at least one tail, there's also a formula for that called the complement rule, which you already know about. I'm just trying to think, did we do the complement rule back here? I don't think we did. When we did with basic probability. I don't think we talked about it in here, but it's going to come up at some point. Oh, yeah, it was here. So the complement rule. So you can either do directly what you did, Georgia, or you can use the complement rule. And that's what this other value is here. Where am I at? But the probability of getting no heads and at least one tail are complements from one another, and that's why you can see it by counting them. But there's only one of these that doesn't have any heads, and it's that one. And so 1/8 and 7/8 are complements of one another. At least one is the complement of no heads. All right, let me see if I can find one more good thing for y'all to do, and we'll probably just get out a little bit early today. Like I said, I wanted to just make sure you have enough to get you started, because some people that I notice that they like to get in and do things. So I want to make sure that they have what they need. All right, kind of get going. There was something else. Those are just the most common ones. the boy and the girl type thing, of coin flips. Here's a neat little one. Okay, here's a sample space for making a sandwich. It's got 3 components to it. Okay. I kind of think that this maybe is being like, I don't know if you ever been to one of these catered things where people have like the little sandwiches out, and they're always like a little bit different ones. Some have wheat bread, some have white, and you'll have just different things on them. So let's just say they're all out there of getting, and they're all out there, before anybody's had a chance to pull all the, ones everybody likes on. Okay, let's just say the first one is simple. What is the probability of picking a ham sandwich? Well, first of all, look, how many different sandwiches are there? Types.
3.
2
3.
times 3 is 6, and then times 2 is 12 different sandwiches, right? White ham cheddar, white ham Swiss, white turkey cheddar, white turkey Swiss. So let me just put this here. The total outcomes are 2 times 3 times 2, which is 6 times 2, so there's 12 possible sandwiches. Okay. So again, I'm trying to get you used to using the counting principle, because those counting methods are going to be what we're going to do, because we may not always be able to see these. But most probably we won't be able to see these. So, because you notice how that fills up the screen pretty well. Let's say you wanted to add like something on there like mayonnaise or mustard. Well, you're going to all of a sudden have to have a lot larger tree diagram, where you're going to have things real small where it's hard to see them. Okay.
Is it 1 out of 6?
Well, but there's 12 different choices. So 12 has to be the denominator to start. Now, it may simplify out to 1/6, but how many of them?
2. It's 2 out of 12.
2 out of 12. Because you got white ham. So
4 out of 12.
We got 1, 2. That's ham. 3, 4. 4 out of 12, right?
Yes.
4 out of 12.
You can always look back a row also and just do 2 out of 6 when you have a diagram like this.
Yeah, you could. Because you can see in there. So then that's 1/3, right? Okay, so again, there's 12 of them. So how many are we talking about that have Swiss? We got 1, 2. Go ahead and see if y'all can figure it out.
6 out of 12.
Anybody else concur with that?
I concur. And 6 out of 12 reduces to 1/2.
Yeah, so there's 1, 2, 3, 4, 5, 6. Let's see if I can come up with one last one. All right, so yes, this Thursday is what they call the conference day. So we're supposed to be in conference all day. You know, and usually it's like at the convention center or something like that, but of course going to all be online, but they're still having it now. I got a funny feeling we may not even have that because if this storm continues to strengthen and kind of still comes on the same track, we probably won't even have that. But
You mean a conference like amongst teachers or a conference? Yeah. Okay. Because this is a conference, so I wasn't just wanted to be 100% clear.
Oh, okay. Yeah, I see what you're saying. Yeah. Yeah. I mean, it's.
So no class on Thursday.
Right. And then the following Tuesday, if I'm more correct, is fall break.
That's correct, for sure.
Right.
Thank
so
you.
I'm glad they're together. But like I said, I got a feeling that we're going to probably be even canceled out of the conference. This storm, unless it goes off somewhere
else. The last
else.
one I saw with the storm was it might not actually hit until later in the weekend, so it might still.
Well, yeah. The last thing I saw, it said like Saturday morning in Baton Rouge.
Yeah, it went from Friday morning all the way to Saturday afternoon. Last I saw. So.
But the thing is if it keeps pushing back, you don't know what's going to happen, but they'll cancel on the early side if they do it because they want to have people get enough time to prepare. All right, so what's the probability of getting a turkey cheddar sandwich? Anybody figured that out yet? Turkey cheddar.
2 out of 12, so 1/6.
All right, so let's just make sure. So turkey cheddar right here with white bread. That's the only one up here on the white bread side, right? And then turkey cheddar on the wheat. So that's 2 out of 12. 1/6, right? Make sense? Let's make sure. Turkey cheddar. So one turkey cheddar here, one turkey cheddar there. And then, you know, if you wanted to do something simple, like, so you're trying to at least moderately pretend to be healthy. What is the probability of getting a wheat bread sandwich? Well, how many of them are here? That's like second half, right?
Literally half, yes.
Okay.
That's easy.
All right, so like I said, I would, if I were you, I'd make a point to try to get on this and just start trying to get started on it, because, you know, it has a tendency to build up. And I can just kind of guarantee you this, that 10.5 is where we start putting together those counting methods with the probability. And so that can get a little bit more complicated. So try to get in and make sure you understand these basics of probability, which is really what this is here. All right, so I think I got everybody that was here. Let me look one last time. Did anybody come in extremely late? So I got everybody. So if you don't have any questions, you can head out. I'll stay here for a few minutes and answer
Thanks.
any questions. Yeah. Okay.